Hello everyone, I am Dr. Sirajul Akfaisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about spectroscopy and especially terms used in UV visible spectroscopy. So let us start. The term chromophore. Chromophore is defined as the nucleus or any isolated covalently bonded groups responsible for the absorptions of light radiation. Any group which exhibit absorptions of electromagnetic radiation in visible or ultraviolet regions. And some of important chromophores are carbonyls, acids, esters, nitriles, ethylenic groups. So absorption characteristic of some common chromophore. Carbon-carbon double bonds, example ethene, excitation N2 pi to pi star, lambda max 171, epsilon 15,000 and solvent hexane. Carbon-carbon triple bond chromophore, example 1 hexane, N2 pi star, 118 nanometers, 10,000 and solvent hexane. Carbon double bond oxygen chromophore, example ethanol, excitation N2 pi star and 2 pi to pi star, lambda max 290 and 180, epsilon 15 to 10,000 and solvent hexane in hexane. And double bond oxygen nitromethane N2 pi to pi star 275 and 200, epsilon 17 and pi to pi star epsilon value 5,000, ethanol solvent. And if you have CX, X is equal to Br, methyl bromide, methyl iodide, N to sigma star, 205, 255, epsilon 200 to 360, hexane and hexane. So AUXOCHROME. These are coordinatively saturated or unsaturated groups which themselves do not absorb radiations, but when present along with a chromophore enhances the absorbing properties of chromophore, also known as color enhancing group. All AUXOCHROMEs have one or more non-bonding pair of electrons, NH2, OH, OR, COOH. It extends the conjugations of chromophore by sharing the non-bonding electrons. So you can see the AUXOCHROME: benzene lambda max 255 nanometer, phenol lambda max 270 nanometer. So hello friends, I am talking about the AUXOCHROME: benzene lambda max 255 nanometer, phenol lambda max 270 nanometer, and aniline lambda max 280 nanometer. So absorptions and intensity shift. Bathochromic shift or red shift. When the absorption maximum lambda max of a compound shift to longer wavelength, it is known as bathochromic shift or red shift. The effect is due to the presence of AUXOCHROME or by change of solvent. Example, the N2 pi star transition for carbonyl compounds experiences bathochromic shift when the polarity of solvent is decreased. Hypsochromic shift or blue shift. When the absorption maximum lambda max of a compound shift to shorter wavelength, it is known as hypsochromic shift or blue shift. The effect is due to the presence of a group, causes removal of conjugations or by change of solvent. You can see in this example, aniline react with HCl forming ammonium and Cl-. So aniline show blue shift in acidic medium since it loses conjugations. Aniline 280 nanometer and selenium 203 nanometer. So hyperchromic shift. When the absorption intensity epsilon of a compound is increased, it is known as hyperchromic shift. The introductions of AUXOCHROME usually increases absorption intensity. You can see pyridine lambda max 257 nanometer, epsilon 2750, 2-methylpyridine lambda max 260 and epsilon 3560. Hyperchromic shift. When the absorption intensity epsilon of a compound is decreased, it is known as hyperchromic shift. The introductions of a group which distorts the geometry of molecules causes hyperchromic effect. You can see the naphthalene epsilon 19 thousandths and 2-methyl naphthalene epsilon 10,250. So shift and effect. You can see the red shift and blue shift, hyperchromic shift and hypochromic shift. Absorption versus lambda max. So, my friend, absorption bands. The formation of absorption bands. The spectrum consists of sharp peaks, and each peak will correspond to the promotion of electrons from one electronic level to another. During promotion, the electron moves from a given vibrational and rotational level within one electronic mode to the other within the next electronic mode. Thus, there will be a large number of possible transitions. Hence, not just one but a large number of wavelengths which are close enough will be absorbed, resulting in the formation of bands. So, types of absorption band. K-band. K-bands originate due to pi-pi star transition from a compound containing a conjugation system. Such type of bands arise in compound like diene, polyenes and enones. Acetophenone pi-pi star transition 240 and epsilon 30,000. 1,3-butadiene pi-pi star transition 217 and 21,000 epsilon. R-band. R-band transition originate due to N2-pi star transition of a single chromophoric group and having at least one lone pair of electrons on the heteroatom. These are less intense with epsilon value below 100. You can acetone into pi star 270, epsilon maximum 15, acetaldehyde into pi star 293, epsilon maximum 12. B-band. Such type of band arise due to pi-pi star transition in aromatic or heteroatomic aromatic molecules. Benzene shows absorption peak between 230 to 270 nanometer when a chromophoric group is attached to the benzene ring. The B bands are absorbed at longer wavelength than the more intense K band. So benzene pi-pi star transition, phenol pi-pi star transition, lambda max 255, 270 and epsilon value 250 and 450, 1450. E-band. E-band originate due to electronic transition in the benzenoid system of three ethylenic bonds which are in close cyclic conjugations. These are further characterized as E1 and E2 band. E1 band, which appears as shorter wavelength, is usually more intense than the E2 band for or the same compound, which appears the longer wavelength. Benzene, naphthalene. You can see 184 to 21, epsilon value 50,000 and 1,33,000. E2 band 2004 or 204 and 286, and E2 band 79,000 and 9,300. So friends, I will discuss Beer-Lambert's law in our next video. So if you like this video, then subscribe my channel, and thanks for watching.